This video's on the question whether vegan or vegetarian plant-based type diets are appropriate for all stages of life. We've heard a lot, a number of organizations pushing this line. Eat Lancet in particular, which is basically an organization funded by people that are associated with a vegan diet, and also large elements of also the World Health Organization, which also on their panel have a lot of people who are plant-based. So it's not really an objective. It's very much driven by politics and opinions, and those organizations are very politically motivated. Now, there's this recent sort of study that this was back in 2019, and this was was in the actual news back then, neuroscience, and the title was "Vegan and Plant-Based Diets Worsen Brain Health." The summary of this: eating a vegan or plant-based diet can be bad for your brain health, especially if you already have a low choline intake, researchers report. This was in the BMJ, the British Medical Journal, so quite a prestigious journal in some people's eyes. The momentum behind a move to a plant-based and vegan diets for the good of the planet is commendable. Well, no. Growing more kibble with petrochemical inputs that basically create monocrop cultures and reduce biodiversity, have a lot of petrochemical and other inputs that are run off into the waterways, I wouldn't consider as a commendable thing for the planet. And plus the erosion and quality of the land has declined. The topsoil loss has been quite considerable since we've been increasing, since the Green Revolution and all the petrochemical inputs. Now, I know there are people like Richard Burgess and others that basically are champions of that. They don't believe in having animals to rebuild soils. You should euthanize them. But that is sort of the misanthropic cult of veganism and their sort of very skewed way of viewing these sort of things. The reality is that the plants do not rebuild soils. They take minerals and they take nutrients from soils. You need animals to rebuild soils. Animals are part of the mix. In the wild world of the wilderness, in these forests and stuff like that, you have an interplay between animals and plants. Animals will defecate and urinate and rebuild soils, and they will move on, and they will not overgraze because there are predators always pressuring them to congregate together so they don't over and moving in constant movement, which basically reduces grazing pressure and also increases nutrients provided by those animals as they move through the landscape. So that's really important as a take-home message. That's worked for hundreds and hundreds of thousands of years before modern agriculture. Grain-based agriculture is the problem. If you take a look at, the desertification of places like around the world, take a look at the so-called Fertile Crescent, which was in the Middle East. It's very arid and desert-like nowadays. Why? Because the soils were depleted so badly. Now, you don't get it everywhere. So places like India and places like China, so the Yellow River, and places like Egypt, the Nile River, these sort of areas, you've got the Ethiopian plateau that basically feeds water and silt into that and rebuilds those soils with minerals and siltation that coming from the mountainous area. The same thing happens from the Tibetan plateau for India and China. That's why they've got big populations. These countries have had big populations from antiquity because of these massive river systems and the massive nutrients that can come from these very high plateaus that are mineral rich. That's the difference. In areas where this doesn't happen, and you apply grain agriculture, you over the time will get desertification and a lot of soil erosion, because there's nothing, you've got to find the inputs from somewhere. Now, in some parts of the world, they mitigated that to some extent with animals, using animals to defecate and all that. It was sort of the sort of crop rotation we had in Europe, where animals were moved around and you farmed only plots of land here and there. And there also they had very deep, good soils because of the animals. That's what they had to use. In other parts of the world, they didn't have to use as many animals because they had this constant new nutrients coming in from these highlands that used to basically feed, water from these mountainous areas, and new silt, new soil with minerals. And that's the difference why these places could get away with it. And in Europe, you had to actually have crop rotation, a whole lot of animals to be able to do that. The modern era with the Green Revolution back in the 60s, that transformed petrochemical inputs and all that. And it allowed us to basically go around and decimate forests and just get rid of them completely, and just basically put grain agriculture on steroids. It's grain agriculture that's decimated these areas. If you go to Northern Australia, there are wildlife areas there, and there are, there's no grain agriculture. And these areas are very arid areas. And you've got animals that are basically being, moved through those areas, which are grazing, domesticated animals that are grazing and doing it year in, year out. And as long as you move the animals like the wildlife would be moved by predators, you don't get erosion, you don't get any damage, you don't get over grazing. And then those animals defecate and urinate like the wildlife and rebuild those soils. And that's what they've said. That's why it's sustainable. They can do it year in, year out in a sustainable way. But if you go to other areas of Australia where there's a lot of grain agriculture, you don't see that. You don't see that at all. What you see is a lot of erosion and a lot of pollution in the river systems, like the Murray-Darling River system. The reality is it's grain agriculture, or as I call it, kibble agriculture, that basically is decimating the planet. So going more plant-based isn't going to help things, it's going to make things worse. And taking away the animals that actually build soils is going to take away the alternative we'll need in the future. And already the petrochemical industry have said by 2025, we could get at peak oil. The technology has pushed, maybe technological solutions, maybe where we can get more. But then you've got the other element. The more you basically go down this pathway of decarbonizing the economy, then the petrochemical inputs are going to become more expensive, because it's economies of scale that bring down the price. If you're only producing just petrochemical products for agriculture, for fertilizers and stuff like that, what you're going to do is you're going to skyrocket the cost, because there's not going to be as much profit, and only some companies are going to remain in that game, which will mean that either government will have to subsidize it, or it will basically become far more expensive. So, this sort of panacea now of cheap grain agriculture is going to change in the future. And we can't afford going down this path, because we know how destructive it is to the planet and how it has been. Anyway, let's move on, because that's not the purpose of this video. But risk worsening, as already low intakes of essential nutrients involved in brain health, warns nutritionists in the online journal of BMJ, Nutrition and Prevention and Health. To make matters worse, the UK government has failed to recommend or monitor dietary levels of this nutrient, choline. I've talked about choline quite a bit. Found predominantly in animal foods, exactly, says Dr. Emma Derbyshire of Nutritional Insight, a consultant specializing in nutrition and biomedical science. Choline is essential dietary nutrient, but the amount produced by the liver is not enough to meet the requirements of the human body. I've discussed this about, I've got the sort of the genetics that don't help me in this regard. Choline is critical for brain health, particularly during fetal development, when kids are still at the fetal stage inside the mummy, It is also influences liver function with shortfalls linked to irregularities in blood fat metabolism. Basically, think fatty liver, as well as excess free radical cellular damage. Yes, not enough choline, you get far more cellular damage. The primary sources of dietary choline are found in beef, eggs, dairy products, fish, and chicken, with much lower levels found in nuts, beans, cruciferous vegetables such as broccoli. You don't really get much in plants, and even the stuff you get is certain bound and much harder to get to. It's like the protein availability and all that, the poor utilization. That's another aspect, but I'm not going to go into that. So in 1998, the recommended sort of intakes were the ranges 425 milligrams a day for women to 550 milligrams a day for men, and for pregnant women up to 550 milligrams breastfeeding, especially during the critical role of nutrition has in fetal development. So I'll link this up. She actually says also here, which is good. She says, I'll put this part. This is concerning given that the current trend appears to be towards meat reduction and plant-based diets. She said she commends the first report, the Lancet, to compile a health food plan based on promoting environmental sustainability, but suggests that the restricted intakes of whole milk, eggs, and animal proteins it recommends could affect choline intake. They will definitely affect choline intake. This is the problem with a lot of these researchers. So, their sort of solution is, recommending that if you go further down here, what are we recommending basically in these sort of things? Supplemental strategies will be required. Well, we don't need supplements. We just need a proper species appropriate food. That's just nonsense. But this is a problem with academia. They find a problem, and rather than actually giving a species appropriate solution, they provide us with a solution which is, let's give people high deuterium supplements. Yes, why not? Let it make it part of their lifestyle. Anyway, now this is the actual study. Could be overlooking a potential choline crisis in the United Kingdom. Yes, I'm not surprised that there is a choline crisis. It is a big problem in itself. So choline can be likened to omega-3 fatty acids. That is an essential nutrient that cannot be produced by the body in amounts needed for human requirements. And just goes through blah, blah, blah about this sort of stuff that they've advised for prenatal vitamin supplements should contain evidence-based amounts of choline, whatever. At least they point out this thing, adequate amounts of brain-building nutrients, with choline being listed as one of these, obviously, because it's so bloody important. Unfortunately, in the UK, choline is not yet included in food composition databases, main nutritional survey, nor official recommendations. I'm not going to go through the whole thing. Just basically the take-home message is that we need more of it. And, pretty much in this part, choline is critical for a number of functions across the life cycle, which includes wide-ranging roles in human metabolism, from neurotransmitter synthesis to cell structure and methylation, with choline deficiency being linked to liver disease, fatty liver, offspring cognitive function, and potential neurological disorders, and put in that degeneration as well. Okay. Functionally, choline is oxidized, blah, blah, blah. I won't actually that. methyl donor in DNA and histone methylation. So histones basically silencing genes. So which plays a central role in regulating gene expression and potentially modulating brain function. Choline also influences liver function. We know that. Exports, I've done a video, exports fat out of the liver with a shortfall linked to defective lipoprotein metabolism. Yes, we know. Basically, we end up with fatty liver, abnormal phospholipid synthesis. Phospholipids are very important for the brain, and oxidative damage. So the low estrogen status. So I'm not going to catalyze. So phosphatidylcholine, which I've talked about before, very important for the brain. Conversion of choline via this enzymatic pathway, which is the PMT enzyme. That's one that I have problems with. And basically can both alter choline dietary requirements. So dietary requirements for choline go up because normally that enzyme will go from methionine to choline. The problem is you can basically, if you've got a problem with that gene and it's not functioning well, you can eat a lot of muscle meat, but you may not be getting enough choline. So that's a very important thing, unless you eat quite a bit of muscle meat to get your requirements for the day. So, and usually are much higher because you need for methyl donuts, but also you need for the brain as well. Phosphatidylserine and phosphatidylcholine plays a big role, but so does phosphatidylserine, but that's a different story altogether. But these are very critical, and together with phospholipids, very important for the brain. For the latter, a growing body of evidence exists suggesting that choline requirements may depend on the presence of several genotypes that individuals with these could have choline requirements higher than the current recommended intake. Bloody hell, they do. Much higher in that regard. So basically, in this regard, risk of choline inadequacy, if you've got these things, nutrients particularly critical during fetal development as it modifies brain and spinal cord structure. That means the structure of the brain and your spinal cord, okay, via apoptosis and stem cell proliferation, influencing the risk of lifelong memory function. Yes, your vegan children may become demented much earlier. Possible risk of neural tube defects, very high in low choline mothers. So there's research. These are all these numbers here are all basically references to actually studies that actually show this linkage. Okay. I don't have time to basically cover all these points. I will place this in my description and people can go away and check every single one of these. In pregnancy, choline supplementation is about twice the recommended amount, the requirements. So 930 milligrams. Improve infant information processing speeds. So at nearly 1 gram of intake of a pregnant woman will improve the child when it's born. They tested its processing speed of information, how quick the neurons actually work. So you want a smart kid, make sure they're eating choline rich foods. It has been suggested that additional choline could improve effective cognitive and neural functioning when taken by mothers carrying a fetus with Down syndrome. So mothers that have Down syndrome carrying a child will actually improve the outcomes if they want to take it to full term. So I would really up, but I would also up things like taurine, a number of other things, phosphatidylserine, a number of other things. Phosphatidylserine has actually been shown to turn off a number of genes that are involved in brain neurodegeneracy and other conditions, actual genetics. that was the Tel Aviv University that did those studies. There were actually certain Ashkenazi Jews that have got a certain neurological condition, which basically is corrected completely with this supplementation. So complete silencing of the genes and eliminating the neurological problem, so massive improvements in that population. And amongst lactating mothers, both intake of choline and genetic polymorphism influences choline concentrations in human breast milk. So depending on the genetics of the mother, you can have more pronounced deficiency in the breast milk, and also based on what they're actually intaking. So that has a direct effect on your child, subsequently impacting the level transferred to the infant. Human neonatals are also born with choline blood levels about 3 times higher than maternal levels, indicating higher demands during this early stage, this early life stage. So the early stage life of a child is critical. So actually, I won't do that because I actually remember the size of an infant is about on average, about 3.3 kilograms. So actually, this one actually says it's 3.5 kilos. So the average birth weight of babies is around 3.5. Anyway, I saw a study that actually said 3.3, but anyway, 3.5. There you go. So the average person is about 70 kilos, which is 154 pounds, divided by 3.5. That's about 20-fold. So the sort of difference. So we're looking now, that is 3 times. So there's a 20-fold difference in weight. You have to think about this 20-fold difference in the weight of a child, and this is 3 times more in their blood, the measurement in their blood. So basically 3 times, we're talking about 60-fold. So compared, because of the size, the weight of the child, compared to somebody who's 70 kilos or 154 pounds, to an infant that is 3.5 kilos, the difference is a 20-fold difference. And the differences are 3-fold. So we're talking about a 60-fold difference between the two. That is massive. That is absolutely massive, because it's 3 times that. So there's a 20 difference between the two, and remember, there's 3 times in the blood of the child. See what it says here? Human neonatals are born with choline blood levels about 3 times higher than maternal levels. That means what's in the mother's system, circulating in the mother's system, is a third of what's circulating in the child's. Remember, the child is 20 times smaller. So that basically means 3-fold of that 20 times is 60. So we're talking about 60-fold compared to an adult. That's how critical it is, important in brain development. It's massive. I mean, if you were to, and this is, even if this was, let's say, this is actually mechanistic. They've actually measured this. So it's a mechanistic measurement. So it's not basically some sort of observation or some sort of, it's a relative risk or relative odds ratio. This is basically a measured ratio. This is far more stronger than epidemiology. And even in epidemiology, I mean, you get like with meat 1.15 or whatever, it's less than 2, which you can't even generate a hypothesis. It's statistical noise. It's irrelevant. It's usually basically because they're testing people who are on a sad diet anyway. And it's just, that's the confounding variables, all the other junk that go with the meat. It's not the meat. We know that because in the past people were healthier and they ate more animal products than they eat today. We've swapped 2/3 back then animal, 1/3 plants. Now we're 2/3 or more plants and 1/3 animal, and we're worse. Our health is worse. So how can it be the animal foods? It's just illogical, but that's the current logic that exists in academia, which has been infiltrated by a whole lot of plant-based academics. But we're talking about here 60-fold difference, massive orders. I mean, even if this was an odds ratio within an epidemiological study, it would be magnitudes way beyond even that of basically like tobacco, which is 30 at the top, 10 to 30. This is thousands and thousands of percent, difference. But remember, this is actual measurements. We're actually measuring this in infants, so we know that these levels are much higher. So, but they will vary between infant. So it will always be 3 times higher than what the mother's is. So obviously the mother that's got better nutrition, that child will have 3 times more than her, but far more compared to a child that is getting much poorer levels from the mother. So as you can see, the body's trying to get as much nutrition to the child, but it will vary depending on what the mother's. I'm not going to go to the recommendations. They can be found basically in places like this, where you can actually see the recommendations here. This is on the Choline for health professionals. I'll actually link this. So this is what they recommend. There's the adequate intake, which basically means it's way below par if you don't have the right genetics. Your best sources: beef liver, hard-boiled eggs, things like beef, as you can see. Now, when we actually look, and this is really the important thing, this is from her study, and this is actually where they've done proper measurements, which I like because they've actually done proper measurements. The other recommendation stuff is not measured to the same accuracy. It's sort of estimated in many regards, especially with the plant-based stuff. This is actually actually done properly. And I'll just go over to here so we can actually see it better. As you can see, this is 100 grams. So 100 grams is 3.53 ounces for precision. And just going back to that of eggs, which is important. These are different sized eggs. So this is a large egg, 147. And if we go back here, we will actually see 147 is definitely divided by 226. It's about 65. It's basically one of the larger eggs, the one that they've got in the studies. Most, the average egg is about 50 grams. So that's 2 eggs here. Those are quite larger eggs. That's why it's slightly higher. So 226 divided by 2 is 113. And those are old measurements when we had less, when they were done many years ago, you had more nutrients. Now the eggs, these are basically your regular supermarket eggs, which is 113. It's much lower because the quality of the feed that the chickens are getting is lower. So we need to use current information. This is current information, which is much, much better in terms of, because she's actually gone away and actually measured these things with current foods, which is very important, rather than the RDIs, which are based and stuff measurements, which are quite dated in some regards. So less use in this regard. So when we're looking at beef liver, obviously you're not going to be eating beef liver every day, but you can get quite a bit amount. But really, you have to eat animal foods. You take a look, nuts, too many almonds. That's 100 grams of almonds, 3.53 ounces, and you're not even getting. You're getting about 10%. You can't eat that amount. 40. I mean, we know about the bioutilization isn't as good, and at 40 to get to the 4 to 500. I mean, that's broccoli. So. Oops. 550 for men, for instance, 40.1. That's 13.7 times 100. That is nearly 1.4 kilograms of broccoli. Forget it. It's not going to happen. Plant foods are very piss poor. This is why there's such high deficiency amongst plant-based people. It's not accidental. Now, if we look at the actual animal foods, like let's say you're having a big steak, so that's human breast milk. Now, I wouldn't. That's the sort of quantities you'll get. So, for a child, remember the 130. Probably a child will probably get that even more. They'll actually even get more. But let's say 3 times. That's the equivalent. And the child will actually get more than that in a day. So probably get, far more than that. Three times that, if it's breastfed sufficiently through the day. So that's, and the mother's got, and remember, this is the sort of your regular average mother. A carnivore mother would have more milk, higher levels, and a vegan mother would have much lower levels. So that's the other aspect as well. So, not all human milk is made the same. Let's put it that way. It depends on the person and what they're actually putting into their bodies. So let's say beef, as an example, you are having like a pound of beef a day. So pound times, divide that by 2.2. So that will give us 454 grams. So just slightly less than half a kilo. So I'll divide that by 100. So, and then we can times that by the amount, which is 104. So you're looking at 472. So plus, let's say 3 eggs, 226 plus 113. So that's about 800, way over the RDIs. If I minus that and minus that, so basically, if you had a pound of beef and 1 egg, you would get more than the RDI as a male, pretty much. So it's very easy on animal foods to get the RDI in that regard. If you've actually, on the other hand, like me, have the genetic SNP that disadvantages you, you may need double. So then, it changes the whole ball game. So then you're looking at plus 226 plus 226. So you're looking at plus. You're looking at pretty much to double that, pretty much a pound of meat plus 5 eggs to get to those levels. To get to the levels where you double it, because remember, you also need choline for neurotransmitters. You need to produce basically phosphatidylcholine, for the brain. So you need to basically, it's also for your lung surfactant, for your, so it's used in structural material around the body as well. Palmitate and, so good air, sort of air exchanges to happen, gas exchanges, to happen, you basically need, you know, the basically that as a building block, very critical. The other one is palmitate, which is another saturated fat, which animal products have shitloads of. So very critical in that regard. Plus methylation to methylate away homocysteine. You know, it's another reason why that video showed such high levels of homocysteine amongst plant-based people. It's not accidental. Again, you know, you need both pathways to basically support that. And they are deficient in both pathways, the B12, you know, insufficiency and the choline insufficiency in their diet. So they suffer from both pathways. Methylation pathways are not supported on a plant-based diet. So another reason why it's very dangerous and for the human body. So now if we went for something like, you know, pork, for instance, 78.2. Now I'll go for chicken, which is even lower, 61.8 times 4.54. So that's about 280 and a half plus so basically a pound of chicken and basically 3 eggs would pretty much cover it for the, you know, your requirements. But if you basically are somebody that's got the genetic issue, then you would require far more. Now, this is the one here. So in this regard, so that's its position within that gene, and basically the single nucleotide polymorphism is basically, you know, leads to V175M valine to methionine at amino acid position 175. Substitution in the PEMT protein and is a loss of function mutation. So it loses the functional capacity to work as well as in other people. And Caucasians with non-alcoholic fatty liver are more likely to carry the T allele, so one of them, with the effects being pronounced, that means worse, with 2 of them. So that's polymorphism. This is homozygous. So you've got 2 of the same, you know, so, and pretty much the carriers, however, carriers are not generally likely to have fatty liver. That means with one allele, based on a study of more patients, including Hispanic and Afro-American descent. But generally speaking, Caucasians have a different distribution of the SNP than do Hispanics and African Americans. Exactly. People who are descended from Europe have more of this. That is why it's far less in the other populations, but doesn't mean that they are not affected to some extent, some portions of their population, at least 20-odd%, depending exactly which regions of Africa they come from, their ancestry originates from. Having this SNP may be necessary, but is not sufficient to cause fatty liver, as many individuals with this SNP have normal liver fat. That's true as well. You know, if you're not engaging the Randall cycle, you're not doing a lot of other nasty things. Probably this SNP does slow export of fat from liver, but only carriers, individual who take it in too many calories too quickly, overeat, will wind up with fatty liver. So what the saying is, when we're talking about excess calories, we're actually talking about excess energy. We know the Randall cycle, basically. So when you have excess energy and you blockade, you end up with a Randall cycle. Too much energy coming from fat and sugar in the system, in the bloodstream, finding a place to be utilized. The receptors have downregulated in the cells, so you basically are going to be pushing, and not enough choline. You're not going to be able to export it out, which basically means you will start building up fat in the liver. That's fatty liver for you. I've made a video covering choline as something along the lines is choline is fatty liver, choline deficiency. Bloody well is. On an animal-based diet, you get sufficient choline to avoid fatty liver disease, basically. Now, when we look at the different populations, we'll look at the European population. So that is the one that I've got, the TT alleles. So that's the homozygous. And basically 56% of Northern European descents, people with that sort of ancestry, pretty much have a very high issue. It's why amongst people of Northern European ancestry have much higher fatty liver issues, because their requirements for choline are much higher. Their intake of eggs, dairy, eggs and meat was much higher, and organ meats. And so that's the real secret, because in Europe you had much, compared to Africa, where there was a lot of tribal populations and hunters and gatherers. You didn't have a lot of. It's only in the modern era where we've seen an explosion in the population in Africa. In the past, it wasn't as big. It's what actually forced a lot of our ancestors out of Africa to find new hunting grounds. But exhausting animals and the actual, also the collapse of the megafauna around the world really changed the circumstances. And also they were also able to find far more animals in the other parts of the world that were, especially in the Eurasian steppes and plateaux, they were able to find a lot of animals which they could domesticate. So they were able to domesticate animals and also find sufficient plants to domesticate as well. This is what really changed those parts of the world, and also river systems that could support and rich soils. So there were a lot of factors why they were able to shift, and we didn't see a collapse in population, but people were able to shift to utilizing these wild grains over time for other purposes, and also domesticate animals because they could find them. If you look at the type of animals that existed, the animals that brought about the horse, that brought about the actual the sheep and goats, and the sort of the cows and the steers and all that, they were already existing there, and they were animals that were much easier to domesticate, and that's why those populations were able to shift to those things much easier. There were certain animals that were close to the Middle East and close to the Horn of Africa, and that is why we see this sort of pastoral type development in the Horn of Africa, Somalia, Ethiopia, and all that. And that's why we saw also, moving from tribal into big kingdoms as well. Somalia, was trading with a lot of the Middle East and all that, and the same thing with Ethiopia. They were quite developed, while Europe was really a backwater at the same time. It's just basically that they declined like different other populations, but they had great civilizations, those parts of the world. So people seem to forget this. They used to trade with the ancient Greeks, and they traded even with the Byzantium, and then later with the Ottomans. So these areas were not underdeveloped. They were quite developed, but they were sort of decimated because of colonial wars, and that's a different history altogether. But pretty much these sort of areas also had animals that could be domesticated. Areas that didn't have domesticated animals, we didn't see the same. We saw changes in the sort of hunter and gatherer sort of approach, so to speak. So these things, it depends. So it really depends. And we see the same thing in the Americas. Even though the first people that moved into the Americas came from the north and pretty much populated the North American plains and stuff like that, they basically use the same methods as the Aborigines. They just burnt and changed. And that's why these sort of areas burn very easily, because the vegetation is very different. It's been altered to create grasslands. And when you try to bring forests back where there were grasslands, what you do is you make conditions which are very prone to wildfires. And that's what we see in North America. And that's what we see in Australasia. We don't see it in other parts of the world. We seed them primarily in these areas because they were more suited as grasslands. And when you turn grasslands, because the indigenous population is no longer involved in their traditional diet and lifestyle, you turn grasslands back into forests, they have vegetation that easily burns, and that's why they're more vulnerable. That's why we see these bushfires, and especially when governments are poorly managing them and don't understand this ancestral sort of knowledge that they've lost, and they ignore it because they think they're experts. But anyway, that's another issue in itself. I could go on for ages. So pretty much when we look at here, Europeans that don't have these issues, 7.1%. The rest of yous are very at risk of fatty liver and have choline deficiency issues. So unless you're a 7.1% a vegan with that possibility, which is the likelihood of that is pretty low, because we're talking about nearly 93% don't, you're in trouble. In southern Italy, in Italy, it's slightly bit better, but not much better. The Maasai do a bit better because they didn't really have access to eggs. So, they weren't consuming eggs. They weren't consuming, they consume a very small amount of organ meats. They don't consume as much. And that's another reason why endogenously they produce more. When we look at the vulnerable populations, this group in Kenya does pretty well as well. But pretty much this Indian population, Houston, does not too bad, but still it's still 60% are vulnerable. But it's really basically people with some European ancestry, like the Mexicans, the Italians, and Northern Europeans. As you can see, Han Chinese 1.5, Japanese 6.2. And we know why that happens is because, their governments a very long time ago, they were imperial governments, basically. Some of their leaders, the emperors, were vegetarian, plant-based type thing and restricted a lot of animal foods. As a consequence, these genetic changes happen in the population where endogenously they are able to produce more choline. So that's sort of a fluke of history. A lot of people would have died in the early days until those genes became more dominant in the majority of the population, but that's how it goes. Back then, life was much cheaper. But the reality is their descendants have these, are less prone, are less at risk for fatty liver, much smaller percentages compared. It's the complete opposite when it comes to Northern Europeans. So, and even Southern Europeans. I mean, obviously for them it's 40% and 56%, but at the end of the day, they're still high numbers. We're talking about nearly half the population. And if you're talking about both alleles, even the polymorphism, when they have at least one, you're still talking about large amounts of the population. So, I mean, take out 30%, 13%, that's still 87% of Southern Europeans and 93% of Northern Europeans. It's still a big, massive number. So here it is again, maternal choline concentrations during pregnancy and choline-related genetic variations as a risk factor for neural tube defects. You can look at all these different issues. They're not very good. Let's put it that way. Alzheimer's. You name it. You name it. There are issues related to it. So we need to basically get sufficient stuff in there. And that's critical. Animal foods are critical for all stages of human life, but especially in early childhood and at a fetal stage, these nutrients are critical for brain development and spinal cord development. if you want to avoid major neurological and other deficits and all that, you really need. And all I can say is to people who are plant-based, I mean, there are supplements out there, choline supplements. I mean, if you're so ideologically driven that your ideology comes first, at least do the right thing by your children and supplement choline. Please do it. It's very critical for their brain development. Plus, because they're not getting enough, they're not eating animal foods, taurine as well. I would add to that as another important element. Because usually at a very young age, a child does not actually it gets taurine directly from the mother's milk. It does not actually synthesize it. It's later. So even taurine is very critical at those early years. So please do not neglect your children. So now you know why I got quite sick. Because choline for me is really critically important. My mother used to give me organ meats when I was young. And then when I became an adult, I thought I was smarter. Yes, wasn't I completely wrong? This is a review on the impact of dietary intervention on cognitive development of Kenyan school children. This is just, it provides a general description that they basically did 12 schools with a total of 555 standard 1 children, equivalent to US grade 1. And what they did was they randomized one of the feeding interventions. So one of the feeding interventions was meat, milk, extra calories, which is basically from oils. So they got extra fat. The control that had no feeding, and that's a good thing. This is actually a good study. It's a randomized study, but it also has a control, which is critically important because some of them don't have controls. And this is not an observational study. This is not an epidemiological study. This is not where, this is a randomized control study, okay? People were either given additional supplemental meat, milk, energy, or absolutely nothing, just their standard diet. And basically this feeding continued for 7 school terms, 21 months. Okay, then they did cognitive tests, were administered before the commencement of the feeding, during, and other terms of feedings. So they basically they checked at the beginning, which is important. You get a baseline. Then they actually checked at the middle, and then they checked right at the end. And they assessed based on this Raven progressive matrices to see how they performed in a number of tests, to see the speed of their brains and stuff like that. This is special, but also they looked at the outcomes. What were their results? What were the results of the kids at the end of the day? So that's what that looked at. Now, this is the actual study. So meat supplementation improves growth, cognitive, and behavioral outcomes in Kenyan children. So a randomized controlled school feeding study was conducted in rural Embu district of Kenya. And this is important. That means it was done in one district, not in multiple districts. So one district where the population is homogeneous, has the same culture, the same dietary practices, the same environment that they're exposed to. So you eliminate all these confounding variables. The children are in the same environment. They're in the same cultural environment, the same linguistic environment. They're in everything similar, so to speak. And they're also in a similar age bracket, another important facet. I mean, sometimes you get these other studies which are basically from somebody from 30 years old to 80 years old. A 30-year-old lifestyle and an 80-year-old lifestyle are going to be very different. So there can be a lot of confounding variables, let alone they're from different areas, different neighborhoods, different cultures, different whatever. This one is everything similar. So we can actually tick off all these boxes. This is a really good study, because it ticks off all these little boxes, oops, they're from the same group. Oops, same ethnic group. Oops, similar genetics. Oops, So all these boxes can be ticked off. That's really important because people can always go, it's probably genetics in that group. No, you can't say that because all of them are from the same district, similar genetics, similar lifestyle, similar culture, similar things. They are rural and they're agriculturalists. They're not, meat-eating people. They are agriculturalists. Okay, they live in an agricultural environment. They produce beans and maize. Maize is their main product they produce. Okay, so let's be quite clear about this. So this is a good study because of that. The reduction in possible confounders. Because even in randomized control studies, you can have some confounders, which can be an issue. It's not like a lock-in. This is nearly a lock-in because it's like basically a uniform prison population where you've got them locked in. The culture and the environment and all that sort of locks them into a certain way of eating, living, and all that, which is great, because in a city setting, people can have different lifestyles, different cultures, not the same. In a rural environment where you've got a specific ethnic group, and here we're looking at this group, Embo people. They come from that area. Okay, so Central Province, that area there, that's the area they come from. So this is the people we're talking about, and that's the area they come from. Okay, so we're talking about a group of people that basically come from a specific area, and that's one of their major dishes from the foods that they produce. So that's very important. So now, 12 primary schools. So basically that district, let me get back here, to test for a causal link between animal sourced food intake and changes in micronutrient nutrition and growth, cognitive and behavioral outcomes. 12 primary schools were randomly assigned to one of 4 groups. Okay, so that's 12 primary schools in that district. Children in standard 1 classes received the local plant dish Dietary, which is this thing here. This is basically a Kenyan traditional meal of maize and legumes, mostly beans of any mixed and boiled together. So they boil it all together and all that. I mean, most of the populations, traditional populations, if they're eating plants, they cook them because that's the only way to reduce the anti-nutrients in that regard. They're not foolish like modern people who don't understand food preparation, even when you're using inappropriate foods. Maize and beans are mixed together in a pot, sophoria, which is a pot of their traditions. That's what they look like. They look like ceramic pots. Water is then added and the mixture boiled until the food is cooked and ready to eat. Dietary is a staple food of all these different population groups of Kenya, but it's also popular in other parts of the country. So the eastern province as well. The beans and maize can either be fresh or dry, but most people prefer fresh because of the better taste. And also when you're actually preparing the fresh ones also, they are softer, and you cook them, they can actually break down a lot of the anti-nutrients much better. So it's probably a good idea as well. It is easy to access because maize and beans are already available in these areas since they are mostly sourced directly from local farms and homesteads. Okay, so I'm not going to go into what they are and sort of the things that they add. They add potatoes and bananas and certain other things nowadays. I mean, potatoes are not indigenous, but they, now they're available in those parts of the world. So they add those things as well, but traditionally they didn't. Anyway, as a mid-morning school snack supplemented with meat, milk, fat added to equalize the energy content of all the feedings. So that's the energy group, the calories group. They added fat, which is in oils. I don't know, even if it's an oil, for a small period of time that they're actually doing it's not going to be that damaging. And it also provides a lot of energy. Fats are still important for development. But they do have different effects because they're not fat soluble. They don't have as many fat soluble vitamins and stuff like that, the oils. So that's another factor to put in there. The control children received no feeding, but participated in data collection. And this is a good thing about it. It's got a control. There's plenty of studies out there, unfortunately, don't have a control group. And the nice thing is it's a homogeneous group. This district, similar people. And they've got a control. So this is what these people are traditional. And then these are all the other interventions, food interventions. And then we look at the outcomes, which is very important. The main outcome measures assessed at baseline and longitudinally between 24 our food intake recall, anthropometry. So somebody measured them, cognitive function. So they checked the cognitive function of the children, the physical activity, the behavior during score-free play. For cognitive function, the meat group showed the steepest rate of increase on the Raven progressive matrices score and in zones, wide scores and end-term totals and arithmetic tests. So in their end of school results, they did the best in all subjects, including arithmetic, so mathematics. And they also basically had the steepest rate of increase. Very important. And I'll show that because they basically came from a lower point, those children. So I was surprised that, maybe the children going to that specific school traditionally were getting less. Let's say it may have been a poorer school, so they were even getting less nutrition than some of the other schools, potentially. That's why they came from a lower base, but still outdid all the others. Very impressive, to say the least. But remember, there was a number of schools. It could have been just one school because they averaged them out, between you got a number of schools and they were 12 schools and they were actually separated. So, if one was a bit on the lower, poorer one that had lower nutrition, that could actually also meant that the average baseline could have been different. But anyway, generally speaking, we saw a steep, and that's the important take home. The meat group showed the greatest increase in percentage time in high level of physical activity, in initiative and leadership. So initiative, we know vegans, brain fogs and all that, very hard to find them to have really motivation. Motivation is very important to have, and animal foods improve motivation of people. They also improve the physical activity side of things, and also leadership. That doesn't surprise me. People that are basically on a species appropriate diet are more confident, less anxious. We know a lot of people who were plant-based before that now have moved to the carnivore diet and actually have seen dramatic changes from having anxiety on the vegan diet, being more confident and stronger on the ancestral diet. So that doesn't surprise me at all. You see it amongst the Maasai who can confront lions with strong will and strong personality. They don't fear. That is an important sign of leadership. Behavior compared with all other groups. For growth in the milk, that's the milk group, only young and stunted children showed a greater rate of gains in height. And we know that because, milk is really good in a number of nutrients, and we know it's got a good level of branched chain amino acids as well. So it's the leucine content. But it's has a few other issues with it, but I'll get into that soon to explain the differences. The meat group showed near doubling of the upper mid-arm muscle area. Yep, they became more muscular. And the milk group, a smaller degree of increase. And that again is because of the macronutrient density of milk isn't the same as meat. That's another important, gram for gram. There is that slight difference. This is a critical thing. This is the first randomized controlled feeding study to examine the effects of meat versus milk versus plants-based snacks of functional outcomes in children. This is actually it. We've got a lot of observational studies that show that if you increase, like there was one study in Mexico where they actually gave one egg to these poor children. And the other group, the control group, had no egg. Only the intervention group got one egg. And those kids that got one egg, just one egg, actually did better. So quite clearly, even small amounts of animal foods can make a big, big difference. So compared to a plant-based diet, or a predominant plant-based diet as those children were on. So this is the first where we're actually properly doing a proper study with interventions, with specific dietary, and then specific outcomes. So let's look at, I'm not going to read all this because otherwise we'll be here for days. Okay, so that's the Raven score. So meat, obviously the top. The one with a fat and the control about the same, and milk dropped a bit. But remember, this is the Raven score, and that's on the day, and so that can vary a bit. So, but it also shows that milk's not going to cut it. So milk does provide certain important nutrients, but it's pretty low in choline, remember? Very low. Mother's milk may be different, but we're actually talking about cow's milk. Cows are dumb. They don't have big brains. They don't require shitloads of choline, remember. Oops. So that doesn't surprise me, that outcome. So when we're looking now at the increase in end of term test scores, so what do the kids actually get at the end of the school year? So we know basically that the meat eaters did better in the tests that the scientists actually did on them. So total scores, the meat group, the highest. The second, that means in all the subjects, was basically the one with the oils. So the more fat, so the ones that actually got more fat actually did better in all the other subject matters. The ones in the control actually went backwards. Doesn't surprise me. This is a phenomenon in Africa, in areas where there's a lot of people that actually eat plants and have basically very poor nutrition, are undernourished, and their children have a lot of poor outcomes. And compared to the kids living not in the rural areas but in the city areas, the IQs are dramatically different. And the reason is because better nutrition. Even the junk food has got more animal food in it and they do better. So it doesn't surprise me in that regard. So even in arithmetic, very poor, the control group. Now, this group that got the energy, the extra calories, so the extra calories basically from oil, that means they were still eating the traditional. So as you can see, just adding oil, additional fat, makes the difference between the traditional. But the milk did better in arithmetic. Why? B12. There's more B12 and riboflavin. Riboflavin is very important for the electron chain, for energy production in the mitochondria. And milk is very high in it. So is meat. And also, milk is very high in B12. We know a glass of milk will give you all, that's for an adult, all the B, like a 16-ounce glass of milk will give you all your B12 and all your riboflavin. That is really important for this part of the brain, the left hemisphere, which does a lot of computational stuff and needs to, do very discrete type, very important calculations, simulate those calculations. So to do that, you basically really need, that faster performing. And we know that brain fogged, B12 deficient, plant-based people just can't cut it. That's where the difference is. But the fats are also very important. We know this diet here, glass of milk and a lot of kibble, just not giving the children enough fat to be able to perform. They definitely perform better. They're getting some fat from the milk, but not enough. These kids are getting substantially more fat. That's why their overall performance is much better. So that's where the differences are coming from, the two sides. The meat ones did the best because they're getting both the fats and the B12s and the riboflavin, which meat is very rich in, and a whole lot of other things, nutrients, which is rich in choline and many other things. So that's where the advantage of so it's better to give these kids meat than give them anything else in that regard, because it'll give them far more advantages in the long run. And that's what this study showed. Now, if we go and look at this higher activity, so as you can see, the meat, better. The control, the poorest. The energy and milk did the same in the high activity, which doesn't surprise me. Then in leadership, we've got the meat always doing better again. The control, the poorest. The milk slightly lower, but that doesn't surprise me because the energy one, the fat, does much better. And for better brain function, you do need general brain function. You do need basically more fat, simply put. The sort of nutrients that you're getting out of milk will help you with computation of the left hemisphere, but the frontal lobe and all that, you need more fat, simply put. And that's where that difference is. Initiative, that's an overall brain thing. So at initiative is basically pretty much the energy in milk, pretty much the same. The control is the poorest, and the meat again wins on. And we notice that amongst people who are basically on animal-based diets, they are basically go-getters. They basically don't. You can't hold them back. They're far more. They're not passive. They're not basically. They're far more. We've got that sort of drive. So now let's look at the mid-upper arms. That's the muscular side. The control. This is where the control is. The control is at a similar level where the milk group is. And the control did the poorest, obviously, because they're eating more plants. The milk one started from the same level as the control, where the calorie children actually started slightly better and still did poorer than the milk. We know bodybuilders have been using milk, for branched chain amino acids and all that. Leucine, again, is the critical component here. The extra fat may help with the frontal lobe, but when it comes to muscle protein synthesis, it's leucine. But with a glass of milk and all that, you're not getting as much leucine. With a steak, you're definitely getting more leucine. So, and look at these kids. They started from a much lower base and shot past all of them. That shows the superiority of meat compared to anything else. Impressive. So for muscle protein synthesis, again, critical is that the density of leucine that you'll get. See, most dairy products, it's only cheeses and things like that are more dense in terms of leucine. Milk is not as dense. That's the thing. If these children were being given dairy, like they were given, not only milk, but also cheese and stuff like that, they probably would be much higher up here, closer to the meat group. But it's the insufficiency of milk in terms of leucine. That's the critical part. There's too much water in it. But it just shows you that there again, that's the take-home message there. I'm not going to go into the rest of it. It's these figures are quite clear. They show quite clear those differences. There, it's perfectly. You want bigger muscles. You want to basically grow a bigger, stronger body as a young man or a young woman. Eat more meat is the take-home message of that. Anyway, this is, on the other hand, which is serum concentration of B12 and folate in British male omnivores, vegetarians, and vegans results in cross-sectional analysis of the EPIC Oxford cohort study. I'm not going to go into it, but I'm just going to point these obvious things in the B12 area. This is amongst all these age groups from 20 up to 78. And as you can see, in these different age groups, there's the vegans, there's the vegetarians, there's the omnivores. And we're talking about kibble eating omnivores here, people that go and eat McDonald's and eat just general shit, but they still, either that small amount of meat, because they're eating far less meat, they're eating 1/3 animal foods and 2/3 plants, these people, compared to the more highly plant eating people down here, they do way, way better. So it's quite clear that if you're on, and B12, I'm not even going to argue it. Even the vegans themselves, academics, accept that B12 deficiency can shrink your brain and cause brain degeneration. I don't have to prove it. There's plenty of studies. It's accepted in the literature by everyone. This is why vegans supplement, and even supplementing doesn't really help them from what we've seen in the research. All it does is adds a whole lot of toxic algae oils into their system, full of aldehydes that rip lipid membranes, and also a bunch of primary and secondary oxidative products. They're rancid, they're crap. When you rip oils out of these plant or any food, you basically no longer, it's not protected anymore in the way it was actually bound, and it becomes vulnerable to oxidation and degradation and rancidity. So, I've shown before the studies about rancidity of oils and a whole lot of things, and Bart Kay's done a whole lot of research on these different products that are out there and their high aldehydes. People want to go, they can go and check his videos out on that regard, and there's plenty of research in the literature covering that point. I'm not going to cover it here, but it's quite clear that the thing is the vegan or vegetarian diet one that is suitable for all stages of life? No, it's not. It is not. This is the reason why we see this appalling brain shrinkage, Alzheimer's, and all that. Choline is very important for those purposes. And if you're not getting enough, you are going to be suffering in the long run from, brain degradation, neurological, myelination, because it's very important also for myelination. So your insulation of your basically, nervous system. All these things require these animal foods, these important nutrients that are very high in animal foods. And if you don't get enough of them, your body will start degrading, not operating correctly. So, is it suitable for all stages of life? I don't think so. Anyway, I hope you enjoyed it. See yous.